Hello friends, welcome to the solution video of mock test 9. In this video we are going to discuss 25 questions which was asked based on control systems. Hello friends, this is Arun Kumar here. I welcome you to my channel Craving Gyan. If you are visiting first time to my channel, make sure you're going to subscribe to my channel and click on the bell icon to get instant notification whenever I upload a new video. So starting with first question, what they are given is block diagram reduction technique is applicable for both linear and non-linear system. This statement is correct. What the reason they are specifying is signal flow graph technique is applicable only for linear systems. Even this statement is also correct, but reason is not talking or reason is not giving the proper explanation with respect to assertion. So I need to go for option B. Nothing but block diagram reduction technique is used for both linear as well as non-linear system, but signal flow graph, in the case of signal flow graph we are going to make use of masses gain formula. This technique is applicable only for linear systems. So option B is going to follow. Next question, derivative of ramp function is a step function. A derivation of step function is impulse. Derivation of parabolic is ramp function. You should know. Integration of impulse function is step function. Integration of step function is ramp function. Integration of ramp function is parabolic function. These things you should know. So the corresponding option that is going to follow is option B is correct. Moving on to third question, what they are given is derivative control is also known as. So this derivative controller is similar to an high pass filter. So it is also called as anticipatory controller, or it is also called as a rate controller. So the corresponding option that is going to follow is option C is correct. Moving on to the next question, what they are given is marginal stable systems are undamped system, underdamped system, critical damped system and overdamped system. We know that in the case of S-plane, whenever the poles are on the imaginary axis, nothing but you will be getting a simple pole at the origin or a poles on the imaginary axis. At that time the system will be a marginal stable system, and that response is an oscillatory response, nothing but undamped system behavior. So the corresponding option that is going to follow is option A is correct. So when the system response is underdamped means whenever the poles are on the left half of S-plane. When it is critical damped means whenever it is at -1. And when the system is at overdamped means whenever the system poles is beyond -1. At that time the system behavior will be a sluggish response or a slow response, and that is in the case of overdamped system. So the corresponding option that is going to follow is option A is correct. Moving on to the next question, what they are given is for the characteristic equation, what they are given is s power 5 plus 4s power 4 plus 22s cube plus 0s square plus 12s plus 6 which is equals to 0. Determine the number of poles on left half of S-plane. In most of the questions they will be asking right half of S-plane, but here I am asking left half of S-plane. So let me make use of RH criteria. So the highest order is s power 5 followed by 4, 3, 2, 1, 0. Let me fill the coefficient. What is the coefficient of s power 5? It is 1. What is the coefficient of s power 4? It is 4. What is the coefficient of s cube? It is 22. Coefficient of s square? It is 0. Coefficient of s power 1, 12, and then s power 0 is 6. Now let me make use of standard procedure in order to get this value. So it is 4 times of 22 minus 1 times of 0 divided by 4. So it is 4 times of 22 minus 1 times of 0 divided by 4. So what you will be getting is 22 only. And what is this value? What is this value? It is 4 times of 12, nothing but 48, minus 1 times of 6, nothing but 42. 42 divided by 4. So I will be getting 42 divided by 4 will be 21 divided by 2. Now what is this value? So we don't want actual values. What we want is there any sign change? So this value is 22 multiplied by 0. It is 0 only, minus 4 times of 21 divided by 2. That one you will be getting as 2. Nothing but you will be getting minus 42 whole divided by this value. That is 22. So I will be getting divided by 22. So what you will be getting is minus 21 divided by 11. So this value will be getting minus 21 divided by 11. What is this value? So this value is 22 multiplied by 6 minus 4 times of 0 divided by 22. So you will be getting 6 only, or you can pull like this. Now what is this s power 1 value? So it is minus 21 divided by 11 into 21 divided by 2 minus 22 multiplied by 6, 22 multiplied by 6 whole divided by minus 21 divided by 11. So what you will be getting is a positive value. So this positive value multiplied by 6 minus 21 divided by 11 into 0 divided by this positive value, you will be getting 6 only. So you will be getting 6 only. So if I am considering an S plane, on the right half of S plane, how many sign changes are there? You can able to find 2 sign change, nothing but 2 poles will be on the right half of S plane. On the left half of S plane, you will be getting 3 poles. You will not be getting any row of 0. Since you are not getting any row of zeros, there is no any poles on imaginary axis. So 3 poles are on the left half of S plane, 2 poles are on the right half of S plane. So the corresponding option that is going to follow is option B is correct. Moving on to the next question, what they have given is you have to arrange the time constants in decreasing order. So if I am talking about an critical damped, underdamped, overdamped and undamped. Undamped means your zeta value will be equals to 0, nothing but the system behavior is oscillatory. And in the case of overdamped system, zeta value is greater than 1, you will not be getting any oscillations. In the case of underdamped system, zeta value will be less than 1 and it is greater than 0. So most of the cases we are going to take the zeta value to be 0.6 to 0.75. So this is the typical value of zeta we are going to take practically. But what is the value of zeta in the case of critical dampness? It is 1. It is verge of oscillation. Now if I am arranging the time constants in descending order, what do you mean by time constants? It is the inverse of the pole location. Now in the case of undamped system, your system will be continuously oscillatory, nothing but you will not be getting steady state error as 0. So undamped system behavior, in this time constant is more. Next one will be overdamped system. In the case of overdamped system, you will be getting a sluggish response or a slow response. But in the case of underdamped system, you will be getting some oscillatory and then it will get settled down. But in the case of critical damps, it is the best system, but you are not going to prefer critical damp system because operating at a critical point is very much difficult. Practical design will not hold good. So the corresponding option that is going to follow is option B is correct. Next question, with respect to pole location, determine the condition on stability of a system when system will be fully stable they are turning. Now consider an S plane. In this S plane, you are going to plot with respect to sigma and j omega axis. Whenever all the poles are residing on the left half of S plane, at that time the system will be a stable system. If you are getting a simple pole or if you are getting a poles on the imaginary axis, then the system will be a marginal stable system. If you are getting a simple pole as well as a poles on imaginary axis, then the system will be an unstable system. Or if you are getting at least one pole on the right half of S plane, then also the system will be an unstable system. What the first option they are telling is there should be no pole on imaginary axis. Whenever there is no pole on imaginary axis, you can't guarantee that the system will be a stable system. The pole may be on right half of S plane. There should be no poles on right half of S plane. This is not the only one condition. These two conditions also should be satisfied. And the third condition is there should be no any repeated pole on imaginary axis. Even this statement is also a true statement. So all these three statements should be hold good in order to make the system fully stable. Nothing but none of the above. So what is the first condition? There should be no any pole on the imaginary axis, whether it is a simple pole or a pair on the imaginary axis or a repeated pole. And the second condition is there should be no any pole on the right half of S plane. At that time, if these two conditions are satisfied, then only you will be telling that the system is a stable system. Directly with the help of characteristic equation, how you can tell means when the system will not be a stable system, if any coefficients are missing or if there is any sign change, at that time definitely we can tell the system will not be a stable system. So in order to determine the stability of a system, we are going to make use of RH criteria, because RH criteria is the optimum technique in order to find the absolute stability. So the corresponding option that is going to follow is option D is correct. Moving on to the next question, what they have given is, for the given set of transfer function for a system excited by unit step function, determine which transfer function has a maximum peak overshoot. They are talking MP, nothing but maximum peak overshoot they are talking. So this transfer function I can relate with respect to C of S divided by R of S. So what is C of S divided by R of S? Let me relate with respect to omega n square divided by S square plus 2 zeta omega n S plus omega n square. Now let me consider first option. What is the value of omega n square? Equals to 100, nothing but omega n you will be getting 10 radians per second. Now what is the value of 2 zeta omega n, which is equals to 10? So what I will be getting is zeta, which is equals to omega n is 10, so I will be getting 1 divided by 2, which is equals to 0.5 I am getting. In the next case, if I am considering nothing but in the B option case, so I will be getting 2 zeta omega n, which is equals to 15. What is the value of omega n? I will be getting 10. So I will be getting zeta, which is equals to 15 divided by 2 into 10. So I will be getting 3 and here it is 2. That is 3 by 4, which is equals to 0.75. So I got zeta, which is equals to 0.75. In the third case, if I am considering, I will be getting 2 zeta omega n, which is equals to 5. I will be getting zeta, which is equals to 5 divided by 2 into 10. 5 divided by 2 into 10. So I will be getting zeta, which is equals to 1 divided by 4, which is equals to 0.25. And in the fourth option, what I will be getting is 2 zeta omega n, which is equals to 20. So I will be getting zeta equals to 20 divided by 20. I will be getting zeta equals to 1. So it is critical damped system. It is under damped system behavior. It is also under damped system behavior. It is also under damped system behavior. Right? Now we know that maximum peak overshoot is inversely proportional to zeta. So which zeta is minimum, there you will be getting maximum peak overshoot. So the corresponding option that is going to follow is option C is correct. Moving on to the next question, we have to find the steady state error. So directly we can find the steady state error with respect to what is the input you are giving and what is the type of a system. So how you can find directly means when type is greater than input, at that time steady state error which is equals to 0. When type is equal to input, at that time your steady state error will be a constant value. Whenever type is less than input, at that time steady state error which is equals to infinite. So in this case what they are given is r of t, which is equals to 5 times of u of t. If I am taking Laplace transform, I will be getting 5 divided by s. So in order to find steady state error, I will be getting steady state error which is equals to a limit as s tends to 0, s times of r of s divided by 1 plus g of s into h of s. H of s value will be 1. So what you will be getting is limit as s tends to 0. So I will be getting s into what is r of s? Laplace transform is 5 divided by s whole divided by 1 plus 10 divided by s into s plus 5. Now equate the value of s to be 0. So what you will be getting is 5 divided by 1 plus 10 divided by 0 into 5. So what is this value will be getting? So this value will be an infinite value. What is 1 plus infinite will be infinite. So this value will be equals to 0. So I will be getting steady state error which is equals to 0. So the corresponding option that is going to follow is option B is correct. Moving on to next question, the best system is the one which will be more sensitive with respect to input and less sensitive with respect to disturbance. Similarly, a good student is the one he should be more sensitive or more focused with respect to mock test and revision. He should be less sensitive to social media platforms, example Facebook, Insta, WhatsApp, etc. So the suitable option that is going to follow is option B is correct. So this disturbance is something like noise, which is an unwanted signal. System accuracy depends on number of integrators used. So the corresponding option is option A is correct. Next question, for the given signal flow graph, determine the number of forward paths, individual loops, two non-touching loops. Assume input node to be R1 and output node to be C1. How many forward paths are there? There is only one forward path. There is only one forward path, right? And how many individual loops are there? So this is one individual loop and this is second individual loop. So you will be having one forward path and two individual loops are there, and two non-touching loops. This loop and this loop is getting touched with a single node or a similar node or a same node. So number of two non-touching loops will be 0. So you should opt for 1, 2, 0. You should opt for 1, 2, 0. So I guess this option I have not given. So I'll be giving a grace marks for each and every person. Moving on to next question, for the given open loop transfer function given unity feedback system having g of s which is equals to 10 divided by s minus 2, the system is unity feedback means h of s value will be equals to 1. Now if I am talking about a closed loop system, the transfer function is given by c of s divided by r of s which is equals to g of s divided by 1 plus g of s times of h of s, where h of s value will be equals to 1. So what you will be getting is g of s divided by 1 plus g of s. So how you can write means 10 divided by s minus 2, nothing but you can write it as directly 10 divided by s minus 2 plus 10, nothing but numerator divided by denominator plus numerator. This is applicable if you are having a unity feedback. So the transfer function what you will be getting is 10 divided by s plus 8. What do you mean by s plus 8? The poles are on the left half of s plane. Whenever the pole is on the left half of s plane, the system will be a stable system. So the corresponding option that is going to follow is option A is correct. By looking at the values of loop gain, that is g of s times of h of s, you can't tell whether the system is a stable system or a conditional stable system or marginal or unstable. So if open loop transfer function, in the case of open loop transfer function, if the system tends to be an unstable system, in the case of closed loop system, nothing but if you are providing a feedback, nothing but a suitable feedback if you are providing, the system may tend to be a stable system. So unstable systems will be converted to a stable system with the help of a feedback network, and this is not true in all the cases. So if you want to make the system to be a stable system, proper designing you have to make. So the suitable option that is going to follow is option A is correct. Moving on to the next question, what they are telling is practically we are going to make use of what kind of system behavior, whether it is underdamped, undamped, critical damped or overdamped. So critical damped response is the best response, but we are going to make use of underdamped system behavior. Nothing but we are going to make use of underdamped system. In the case of underdamped system, your zeta value will be lying between 0 to 1. In the case of undamped system, zeta value will be equals to 0, and in the case of critical damped system, zeta value will be exactly equals to 1. In the case of overdamped system, zeta value will be greater than 1. So this is very, very important. So practically we are going to make use of underdamped system, but the best system will be a critical damped system. So this is very, very important. To achieve high speed, we are going to make use of PD controller, PI controller, high controller, none of the above. So to achieve high speed, we are going to make use of proportional derivative controller, nothing but option A is going to follow. And to achieve steady state error approximately equals to 0, at that time we are going to make use of PI controller. Moving on to the next question, what they're telling is 40 dB per decade corresponds to. We know that 20 dB per decade corresponds to 6 dB per octave. 6 dB per octave. Conversion techniques you should know. Similarly, 40 dB per decade corresponds to 12 dB per octave. So, the corresponding option that is going to follow is option B is correct. Next question, optimum value of gain margin in the case of Bode plot is. So, the optimum value is 5 dB to 10 dB. Optimum value of phase margin in the case of Bode plot is 25. Nothing but option A is going to follow. In an RLC circuit, determine the nature of system given resistance value which is equals to 10 ohm and the inductance value they have given it as 10 millihenry and the capacitance value is 0.1 microfarad. We know that zeta which is equals to R divided by 2 into square root of C divided by L, which is equals to 10 divided by 2 into under root of 0.1 micro means 10 power minus 6 whole divided by 10 milli. Whole divided by 10 milli. Milli means it is 10 power minus 3. So we will be getting zeta which is equals to 5 into under root of 0.01 divided by a root of 1000. Moving on to the next question, an open loop transfer function of a unity feedback system as g of s which is equals to 1 divided by s plus 1 into s plus 1, the closed loop transfer function will have poles at. Now what they are given is g of s which is equals to 1 divided by s plus 1 the whole square. Now they are talking with respect to closed loop transfer function. If I want to talk about closed loop transfer function, that is C of s divided by R of s which is equals to 1 divided by s plus 1 the whole square plus 1. So what you will be getting is 1 divided by s square plus 2s plus 2. So in this case the poles are at minus 1 plus or minus j1. So the suitable option that is going to follow is option B is correct. For the system to be a stable system, whenever phase crossover frequency, if it is greater than gain crossover frequency, then only the system will be a stable system. So in the case of Bode plot, first thing what you are going to talk about is gain margin, phase margin, gain crossover frequency, phase crossover frequency. Whenever phase crossover frequency, if it is equals to gain crossover frequency, then the system will be a marginal stable system. If it is less, then the system will be an unstable system. Bode plot is applicable for minimal phase system. So what do you mean by minimal phase system? Means all the poles and zeros are on the left of a phase plane. In the case of non-minimal phase system, all the poles are on the left of a phase plane. Zeros may lie on the right of a phase plane. In the case of all pass system, poles and zeros will be a complex conjugate kind of thing. So the suitable option that is going to follow is option A is correct. Identify the odd one out. Root locus technique, Bode plot, Nyquist plot, polar plot. Most of the persons will be opting for polar plot because polar plot is not a complete plot. Polar plot is a subset of Nyquist plot, like that they will think, and then they will be opting for polar plot. If I am talking about how we are going to find the stability, in the case of time domain analysis, we are going to make use of RH criteria and root locus. But in the case of frequency domain analysis, we are going to make use of Bode plot, polar plot and Nyquist plot. So the odd one is a root locus. So the suitable option that is going to follow is option A is correct. To find absolute and relative stability, the best technique is to find absolute stability we are going to make use of RH criteria, and for relative stability we are going to make use of root locus. So the suitable option that is going to follow is option C is correct. So once you finish with all 25 questions, you have to click on next, followed by you have to rate the quality of mock test. If you think the questions are at moderate level, you can opt for moderate, and if any suggestions are there, please provide your valuable suggestions or valuable feedback. So this will help me for analyzing the further mock test. So the only key mantra to crack competitive exams is proper revision, you have to follow the proper timetable, and you have to take mock tests regularly. If you like the solution video, please give it a big thumbs up. Also share this video with your friends, and don't forget to subscribe to my channel Craving Gyan. All the best for exams. Thank you.